In this video, we will be discussing the topic of deep ocean current.
Our objective for this video is to explain and demonstrate how ocean water density is influenced by salinity and temperature.
Thermohaline circulation is underwater currents in the Earth's ocean that circulate cold and warm water between two poles in the equator. These currents are driven by variations of density in seawater caused by salinity temperature difference.
Salinity in the ocean is the measure of how much salt is dissolved in the water. Evaporation removes the water and leaves salt behind, increasing the salinity. A decrease in salinity can be caused by the continuous input of fresh water from rivers, precipitation of rain and snow, and melting of ice.
Halcyon is caused by a strong vertical salinity gradient within a body of water, so the water that is rich in salt sinks below to the water less rich in salt. It graph shows the increase in salinity as there is a increase in depth.
In this experiment, we will need 4 cups, each a different color. In the first cup, no salt will be added. The second cup will have 1.5 tablespoons of salt, and the third will have 3 tablespoons, and the fourth will have 4.5 tablespoons.
After dissolving the salt, the water, use a pipette to carefully fill the test tube with the liquid depending on their salt density. Fill the tube with dense to less dense.
The result will look like a tower. Because of the different densities, the liquids will stack onto one another.
Moving on to the next factor of density, temperature.
Temperature differences in the Earth's oceans are caused by the amount of sunlight that hits the water, which will make the water warmer. The more sunlight there is, and the colder if there is less direct contact. You're fine.
For this experiment, we will use 2 cups, starting by pushing a push pin about 2 centimeters from the bottom of each cup. Then fill the cup with warm water that is colored red, and the other cup filled with cold water that is colored blue.
You will have two cups. Place them in a tub that will represent the ocean, carefully filling the tub with room temperature water. Fill the tub past the push pins, but not past the level of the water in the cup, or else they will float.
Next, take the push pins out of the cups and watch as the pressure of the water pushes out the warm and cold water.
Because of the red water is warm, it is less dense than the ocean water, causing it to form a layer on the top of the clear water. Because the blue water is cold, it is more dense than the ocean water, causes it to sink.
Studying density difference in the ocean helps us understand currents and how they are influenced by modern-day issues like climate change.
If climate change continues to change the Earth's atmospheric temperatures, the thermocline circulation of the oceans will continue to slow down. This whole process depends on the upwelling and downwelling of the dense and less dense water. Because temperatures are rising, glaciers are melting and causing the salinity levels in the ocean to dwindle.
The currents in the ocean are beneficial to marine life because the upwelling of the currents in the ocean move the nutrients they need up from the seafloor to the surface, spreading them out as they rise.
There are the main factors that lead to the ocean creation of currents in the ocean.